What are the common design rules in plastic product design? The design of plastic products is a complex manufacturing process that involves a wide range of factors and considerations. To create a successful and effective plastic design, designers must take into account several common design rules and guidelines. These rules help to ensure that the final product is functional, aesthetically pleasing, and able to withstand the stresses and strains of its intended use. Draft angles. One of the most important design rules in plastic design is the rule of draft angles. This rule states that all surfaces of the product that will be molded must be angled to allow the plastic to be easily removed from the mold. This is because plastic tends to shrink slightly as it cools and solidifies. And if the surfaces of the product are not angled, the plastic may become stuck in the mold, resulting in a defective part. The angle of the draft required will vary depending on the type of plastic being used, the size and complexity of the product, and the type of plastic injection molding process used. Typically, a draft angle of between 1 and 3 degrees is sufficient for most plastic products. Wall thickness. Another important design rule in plastic design is the rule of uniform wall thickness. This rule states that the walls of the product must be of a consistent thickness to ensure that the plastic can be properly injected into the mold and that the product will have the desired strength and durability. If the walls of the product are too thin, the molten plastic flows may not be able to fill the mold, resulting in a weak and potentially defective part. On the other hand, if the walls are too thick, the plastic will take longer to cool and solidify, increasing production time and cost. In general, plastic parts and components should have a minimum wall thickness that is sufficient to provide the necessary strength and rigidity. However, the exact wall rib thickness will vary depending on the type of plastic being used, the size and shape of the part, and the intended use of the product. For example, a small, simple plastic part may have a minimum nominal wall thickness of 0.5 mm, while a larger, more complex part may require a minimum wall thickness of 1.5 mm or more. Fillets and chamfers. Another important design rule in plastic design is the use of fillets and chamfers. Fillets are rounded corners that are added to the edges of a plastic part, while chamfers are angled edges that are cut into the corners of a plastic part. These features help to distribute stresses and loads more evenly throughout the part, reducing the likelihood of failure or cracking. Fillets and chamfers should be used whenever possible in plastic design, especially on sharp corners or corners that are subject to high stresses or loads. Avoid sharp corners and abrupt changes in cross-sectional area. Another important design rule is to avoid sharp notches or sudden changes in cross-section, as these can cause stress concentrations and reduce the strength of the part. Instead, any notches or changes in cross-section should be gradual and smooth, to distribute stresses more evenly throughout the part. Avoid sharp notches or sudden changes in cross-section. Sharp notches or sudden changes in cross-section can cause stress concentrations and reduce the strength of the part. Instead, any notches or changes in cross-section should be gradual and smooth, to distribute stresses more evenly throughout the part. 6. Avoid overhangs. Another important design rule is to avoid overhangs or sections of the part that extend out from the main body without any support. Overhangs can cause the part to warp or deform during the injection molding process, and can also make the part more susceptible to cracking or failure in use. Instead, overhangs should be avoided or minimized, and any necessary overhangs should be designed with reinforcing ribs or other support structures to provide additional strength and Undercuts. Another important design rule is the use of undercuts. Undercuts are features of a plastic part that prevent the part from being removed from the mold in a straight, linear motion. These features can be difficult to mold, and they may require the use of specialized injection molding techniques or additional tooling to be produced successfully. It is important to avoid undercuts whenever possible or to design them in a way that minimizes their impact on the molding process. Reinforcement. Another common design rule in plastic design is the rule of reinforcement. This rule states that plastic injection molded parts should be reinforced with the additional plastic material flow in areas where they will be subjected to high levels of stress or strain. This reinforcement can be in the form of ribs, gussets, or other structures that are molded into the plastic part. Or it can be in the form of inserts or other components that are added to the part after it has been molded. The purpose of reinforcement is to increase the stiffness and strength of the plastic part, allowing it to withstand higher levels of stress without deforming or failing. Allow for shrinkage. Plastics shrink to some extent when they cool and solidify after being injected into a mold. This shrinkage can cause the finished part to be slightly smaller than the original design, which can affect the fit and function of the part. To account for this, plastic designers must allow for a certain amount of shrinkage in their designs. Injection gate location. It is also important to consider the gate location, which is the point at which the molten plastic is injected into the mold cavity. The gate location can have a significant impact on the quality of the final product, and it should be carefully planned to ensure that the material flows smoothly into the injection mold cavity and to minimize the formation of defects or voids. Conclusion. Overall, many common design rules are followed in plastic design to ensure the strength, durability, and overall quality of the finished product. By following these rules, manufacturers can create plastic parts and components that can withstand the stresses and loads they will encounter in use, and that will perform as intended throughout their useful lifespan.